And so here's problem 8, target problem number 8 on the 2016 state. It's another 3D geometry problem, and they're quite common. And so the polygon here shown is constructed from 6 squares and 6 equilateral triangles, each of side length 6. This polygon may be folded into a polyhedron by creasing along the dotted lines and joining adjacent edges as indicated by the arrows. What is the volume of the resulting polyhedron? Express your answer in your simplest radical form. There's a lot of 6s. And so anyways, the most important thing that you have to do here is really just to visualize what happens. And so what's happening here is that we fold in these 3 get folded in, and we get like a half pyramid kind of. So we have this like square base, and then we fold all of these, and then we get 3 faces. It's kind of hard to see here, but we have this face, and this face. This face is technically empty, which doesn't end up being an issue here actually. But yeah, so we have these 3 faces, this one, and this one. They're filled in, they correspond to, this is face 1, 2, face 2, face 3, face 3, face 4. And then something similar happens on the other side as well. Oh. On the other side, we also have this same we also have the same setup. So like that's face 5, face 6, face 7, face 8. And so we have another triangular pyramid on the left side, square pyramid, rectangular pyramid, a pyramid with a square as the base on the left side as well. And then we fold them together. And when that happens, it's just that like our empty spaces that we had over here and the empty space we had over here, they just get merged together. And so really what the total volume is equal to is just 2 times the volume of like this. It's 2 times the volume of one of the smaller ones. And the volume of one of the smaller ones is base times height over 3, which equals 2 times the base is 6 times 6. It's a square, 36. The height's a bit more tricky, actually. I should give more space for that. So the way you find the height is you first find the slant height. So here's like the face. It's an equilateral triangle, which means that this height is 3√3. So we know that this length is 3√3. And we also know that this length here is 3, which means that the height from the top to the bottom of our pyramid is height is equal to square root of 3√3 squared minus 3 squared, which equals the square root of 18, which equals 3√2. So this equals 36 times 3√2 over 3, which equals 72√2, which is the volume. So yeah, that's all of the problems on the target round and the sprint round from earlier. So yeah.